Blow Your Own 2025. It's amazing that we've been doing this for so many years. My name is Dane Comerford, and I'm the director of If Oxford, the Science and Ideas Festival. And we've got people joining from up and down the UK, and sometimes we even have people joining from abroad, which is great to learn some creative coding and some crafting. It's a joint project. And today we've got the wonderful Vicky and Sophie from STFC RAL Space. I'm going to get them to introduce themselves in 1 second. The whole course is 6 weeks long, and you'll get the most out of it if you join every session and learn over the next 6 weeks. But if you miss a session, that's fine. You can always watch this recording and the other 5 recordings as the workshop series progresses. There are worksheets to go along with it too, and you'll be able to do some Tinkercad making on your computers. And if you're lucky enough to have an Arduino, you can do some real physical building and crafting. So the lead crafter is Vicky. So I'm going to pass on to Vicky just to say hello.
Hi everyone. So my name is Vicky and I work at the Rutherford Appleton laboratory.
Hello everyone, I'm Sophie. I work with Vicky at the Rutherford Appleton laboratory. We make a really good team because I really like coding and things like that, and that's the thing I'm best at. And I love crafting, but the picture I have in my brain often doesn't quite match what comes out when I try and make it with my hands. So between us, Vicky and I can do some really, really exciting things. And that's how we work at RAL a lot of the time. We're all good at different things, and so we work in big teams to achieve all kinds of stuff, to find out the mysteries of the universe. We hope, anyway. We're still looking.
Yeah, there's a lot of mystery to solve, isn't there? The universe.
There is. It's a pretty big place, the universe.
It is quite big. It is quite big, isn't it? So by the end of the session, you should be able to make something like this, or something not like this. It's entirely up to you. So all I've got is an egg box and some flashing lights that spin round and round and round. Of course, the lights aren't moving. They're just going on and off in a sequence. And inside this egg box is a whole bunch of gubbins that you'll learn about over the next 6 weeks. So we've got the Arduino microcontroller here. We've got this white thing, which is called a breadboard, loads of wires and cables. And you can see poking through the top of my egg box some LEDs that are just going on and off in a sequence. So one of the things that we want you to learn is that we might be using things like mobile phones and all sorts of gadgets and technology, that inside there's just this sort of stuff. So there's a little computer or a little controller, some wires and a bit of structure. And on the outside, it's packaged all nicely in a cardboard egg box, or in something like your TV at home, or maybe a mobile phone. But they're not a magic device. They're just a piece of electronic kit. And if you learn how to do coding, you can make that sort of electronic kit yourself. So I'm going to turn that one off and pass on to I'm going to get rid of that.
Now we're going to look at Dane's keyboard. It's a beautiful
How
keyboard.
clean is Dane's desk? Let's see.
This is when the technology doesn't always go to plan with a live event, so it's very much live. So that's what we're aiming for over the next few weeks. And Vicky has something really cool as well that she'll be showing at some point. You want to show it now?
I mean, I can. Sophie appears to have spotlighted me.
Yeah.
So we're going to have a craft project alongside the coding aspect. So Dane's made a lovely egg box with the lights going around in a circle. And we thought that you could make some sort of like planetary landscape, or I've made a Mars landscape. You don't have to do a Mars landscape, but I've made it in a shoebox. It's very exciting. And then if you open it up, we have a Mars landscape and we have a rover, and we're going to eventually incorporate some LEDs and maybe some sensors and some motors into that landscape.
I am so excited about it, honestly. It's going to be very exciting. So Dane's used an egg box, Vicky's used a shoebox, and you can use the coding that we're going to do all kinds of different projects. So I think we're running up to the Christmas Light Festival, aren't we, Dane? So
That's
we can
right.
make some kind of Christmas lantern.
That's right. So it's entirely up to you what you make, but we just want to provide you with the tools and the inspiration to go and make. So we're not going to be making anything physical today, and don't worry if you haven't received your Arduino, because all the stuff today is just online, and you can always take part by using Tinkercad online. You don't always have to have an Arduino to build something. So even if it takes a few weeks for you to get hold of one, it's fine. You can still learn how to do the computer coding and the design in Tinkercad. So this session today is about getting people up to speed with Tinkercad and some of the basics around what we're going to be doing. And then we'll do some building next week. So if everyone's ready, how about we pass on to Sophie and we can start doing our tinkering?
Yes, brilliant. Well, I will first just pop in the chat the link that you need to go to Tinkercad to enter in, and then I will share my screen so that we can all follow along at the same time. If you click on the link that I put in the chat, you should get to this page, and then what we need to do is join with a login code, just like this. And now you've all should have been sent your login code. It's all of this form, so it goes to 2025.glow. And then 3 numbers. And since Dane put me on first, I'm 001, which makes me feel quite special and important. When you've put it in, you click go to my class. If it's not working or you can't remember what it is, pop something in the chat, because Dane has a list of everybody's code, and so we'll be able to help you get logged on. We can all see the exciting and beautiful code that you do. So if you do have any problems, that makes it a bit easier for us to help what you've done, to help figure out what the issue is. This is new. These little bats are cute up here. They make me happy. I hope everyone has fun Halloween plans. But once you're at this point, what you want to do is go down to this thing that says circuits and click create your first circuits design. Okay, so we click this design, and that's what we're going to do. We're going to use all circuits. Tinkercad is a great platform that you can do all kinds of different things. So so you can try out the other bits. You can do 3D designs and all kinds of different bits and pieces. In the chat, if you've got a question or a problem or something, we're really going to do our best to help. What will be really helpful for us, though, is if you say what you need the help with. So if you say it's not working, then we'll be like, oh, that's a shame, but we won't be able to tell you what, to give you some hints about what you can try. So if you say, it says that my login code doesn't exist, then Dane can be like, aha, I know how to fix this. I'll find your login code and let you know what it is. Okay? All right. So I'm going to click on the circuits design, and then nothing's going to happen for a second because it's just being a bit slow. And you should see something like this. So is everybody at this point? You do a thumbs up. If you as a reaction rather than in the chat, that would be really helpful, because then I can just see how far everybody is getting. Oh, just going to make you a bit bigger, everyone, because you've all become really small on my screen. Fantastic. I've got some thumbs up already. Good job. Fantastic. All right. So like Dane said, do remember that this is all recorded. If there's a bit that you miss, or you're like, oh, actually, I didn't quite get that step or something, then you can always go back and watch the recording. Dane is super efficient and normally puts the recording up online the very next day. So you don't have to wait very long to check it out. You'll also get a worksheet that takes you through all of the steps as well, so you can just follow along that way as well. All right, so here we are. ready to start coding. So the first thing we're going to do is we're going to design a circuit, and we're going to use something called an Arduino. Has anyone heard of an Arduino? You can pop something in the chat to say what you think it is. It looks like this. Any ideas? So even if you haven't seen something, oh, brilliant. Yes, it's like a circuit board. Really good answer. Even if you haven't actually seen something like this, you will all have used them. You have them in your houses. What it is, it's like a tiny little computer, or what we call a microcontroller, which is a small thing that controls other things. That's what it does. So what we're going to do is we're going to give it some instructions, and then it's going to complete those instructions. So for today, all we're going to do is we're going to connect it up to a light, and we're going to tell it to turn the light on. And then you remember the shoebox that Vicky showed you. We're going to make that light our star right in the center, and we're going to turn our light on. So I'm very excited to see that next week. So this is our Arduino, and we can send instructions out to any of the things that we connect to our Arduino, okay? But we need to connect it to stuff first. So some of you will probably have used Scratch. So you can use, this Tinkercad works just the same way that Scratch works. You've got all of the different bits that you can use over here on the right-hand side. And if you want one, fantastic. I can see that some of you have used Scratch. If you want a component for your circuit, you just click on it and pull it out like this. If you want to delete it, you just press the delete button. So it's really easy, and just like Scratch. So the next component that we're going to do to build our circuit, which is going to turn our light on, is this thing. Now this is called a breadboard. Hands up if you have used a breadboard before, or if you've heard of a breadboard. No, it's a bit of a funny name, isn't it, for an electronic, oh, someone has, fantastic. Brilliant. Some of you have used breadboards before. That's brilliant. So it's a bit of a weird name for something, but it's actually a really, really useful thing for us to do. So you'll see when we start creating circuits, it's a way of connecting components like lights and wires and buttons and things to each other without having to like wrap wires around around all of the different bits and pieces. So it makes life a lot easier. Because we want somehow to connect our Arduino to our light so that we can send out that instruction to say, please turn on. And the breadboard will just make that easier. Okay, so have you all got an Arduino out and a breadboard out? Put your hand up or do a reaction if you do, if you have. Oh, fantastic. Oh, the heart is glistening. I love that. Great job, everybody. Okay, we're getting through this really well. So I said that our task for today was to turn a light on. It's going to be Vicky's and my star, but it could be whatever you want it to be. It could be a warning light saying, oh no, our spaceship's about to crash. It could be a light in your lantern. It could be anything that you want it to be. For Vicky and I, it's going to be our star. So you look over here on the right-hand side for our light. Now, in Tinkercad, our lights are called LEDs. That stands for light emitting diodes. And it's the word that scientists and engineers use to talk about light bulbs. So that's what we want. And we're going to click on that and bring it over and put it on our breadboard. Now, before I do that, I'm just going to show you one neat thing about Tinkercad. Is sometimes you're looking at all of these things, you're like, oh, I can't quite remember what these different things do. So up here, you see where it says basic, you can change this. You can change it so you can see lots more, or next to basic, you can switch it to what's called detail view. So if you do that, then you get a list, a little description of what each of the different things are. Okay. So we want an LED, and I'm going to pull it out and I'm going to put it on my breadboard. Now it doesn't actually matter where on the breadboard we put it for now. So you can just put it wherever you feel is the best place. All right, you can see it kind of snaps into place. I can move it around if I want to. I can also change the color of it. So Vicky, what color do you think our star should be? Should it be yellow or orange?
It should be yellow.
Okay, Vicky and I are going to have a yellow star, but you can have whatever color light that you want. And what we want to do is we want to send an instruction out from our Arduino to our star, to our light. And that means that the Arduino needs to be connected to our light. All right, and to do that, we're going to use a wire. Now, wires are really easy in Tinkercad once you get the hang of it. To start with, I put wires all over the place. But if you want to create a wire, all you need to do is click where you want the wire to start. So I want it to start over here and my Arduino in one of these little holes, which we call pins. So I click here, and then you can see I've got a wire that draws out, and I can end it wherever I want it to end. Now I want to connect my Arduino to my light, to my LED. And so I'm going to move it over here. So it's in the same column. For me, it's column 23. Doesn't matter which number your column is, as one of the little legs of my LED. So like that. You see? Like this. So the neat thing about breadboards is that underneath these breadboards, all of these little holes are connected in the lines. So if I just hover over here, you can see that some of these have green circles around them. Yeah, you can see the green circles. If I zoom in a bit, sometimes Tinkercad doesn't like it when I zoom in, so forgive me if it crashes. So you can see these little green lines. That means that underneath, everything connected to a green circle is connected. So if I hover over where my wire is, you can see that my wire is connected through the breadboard to one of these cute little LED legs. All right, so now I can send an instruction out to my light or to my star. I can say, star, I want you to turn on or twinkle. Okay, so does everyone have an LED and a wire? Give me a thumbs up or something if you can, if you do. Brilliant. Oh my gosh, you're doing so well, everyone. Little celebration. Fantastic. Great job, everyone. And do remember, we'll say this a lot, but it's important to remember that this is all recorded. And so you can always go back and just check that you got this bit and that you understood this bit, or that it all worked right. Okay. So before we put our next component in, I'm just going to show you a trick that I use. So I'm not very good at looking at pictures and understanding what's happening. I have to concentrate really hard to understand a picture. And it helps me if things are a bit more neat and organized. So this kind of weird line that goes diagonally across there, I find that a bit confusing. So I want this to be nice straight lines. So I'm going to double click on it, and then I can make my wire into nice straight lines. So if you just double click anywhere along the wire, then you can turn it into a straight line like that. And now it looks pretty similar, but when we've got lots of lines and lots of wires going around, which we will do later on because you'll all be brilliant, I find it can really help because it makes it easier. We don't have as many things crossing over each other, and it just makes it easier for me to understand it. It might help you, it might not help you. So you can do it or you don't have to. It's entirely up to you. But it just looks prettier, don't you think? I mean, that might just be me.
It is very tidy. And when you've got an egg box full of wires and it's all looking a bit crazy, sometimes it's quite difficult to find out where the wires are connected to different things. One of the other things that Sophie will be doing is changing the color of wires. So you can choose, and that helps you kind of organize your circuits and breadboards as well. So there's all sorts of little tricks and tips that you can use as you like. You don't have to do them all, just do the ones that are most useful, but you also have to make sure you do obey the laws of physics, which we'll go into later.
Yes. Yeah, we do all, sometimes unfortunately, have to obey the laws of physics. Yeah, so let's talk about one of those laws of physics now, actually. Those of you, has anyone done circuits at school, or have you done them before? Put your hand up if you've done any circuits before. Oh, fantastic. We've got some people that have done circuits. Brill. That's great. Doesn't matter at all if you haven't, because we will go through everything that you need to know for it. So a circuit is, I like to think of it a bit like a racing circuit. So, you know, in fancy places like Silverstone, you get those cars that go super fast and they go round and round and round in circles, and lots of people watch them and get very excited about the cars going very fast. So that is what we call a complete circuit, because the car can go right from the beginning and then it can follow the road all the way around and ends up back where it started. So there's always somewhere for the car to go. And if the car goes off into the road, then that's a terrible thing, and it doesn't finish the race and it doesn't achieve its goal. And electric circuits are just the same. You need to be able to trace a complete route from where you start all the way around to the end. That's where the electricity will flow, and that's where, so we can send our instructions and get our light to turn on. Okay? So we can start by doing this now. So let's start tracing it. We start here in our Arduino. We follow our wire up along. And you can remember, if you double click on it, then you can make it into these nice, neat bends. So we follow our wire all the way along here. We go into the breadboard, through the green circled breadboards, into the LED, back into the breadboard. But then our circuit has stopped. We've got nowhere for the electricity to go. So our car is going to crash, which is not good. We never want that to happen. So I need to create a link back from the LED back here to my Arduino. Okay, that's a really useful tip. If ever your circuit's not working, try tracing it around to make sure that everything is connected. It's pretty easy to do on these on the circuit diagrams. I find it much harder when it's a real physical circuit in place, so I often have to ask some people to help. Great. So the next component we're going to do, we could just take a wire and go from our light to our ground, but actually we don't want that much electricity to go through. We don't want that much power to go through our light, because Vicky and my star isn't shining that brightly. So we're going to use something called a resistor, which just reduces the flow of electricity through the circuit. So it makes this light shine at the kind of level that we want it to do, at the brightness that we want it to do. And it protects our circuit. So you may have heard of resistors before, but they're just there to help control our circuit. So we're going to pick our resistor, and bring it over here so I can move it around. And remember, we want it to connect to the other leg, the other side of my LED. So I'm going to put it here and then down to this blue line here. So you can see now my circuit has got a little bit further. It goes along the wire, through the breadboard, through the LED, through another bit of the breadboard, and then into this resistor. All right. Now, resistors actually have different strengths. So some of them can restrict the electricity a lot, and some of it will only restrict it a little bit. And the measure of the strength, you can change how strong our resistor is by clicking on it. And then you can see up here, I've got some values, and we actually want to change this value. So I'm going to change that to 220. And instead of K and then this funny squiggle, which is called an ohm, I'm going to change it to just an ohm. Okay, I'll zoom into that. Oh, it doesn't zoom into that bit. I'm sorry, it's this bit over here. So that should be 220 and then an ohms. It should still work even if you've got the wrong number. It doesn't matter exactly. You could put 227. It would still be about the same brightness. But we want it to be relatively bright. So that's good. All right. To change the resistor, just to repeat, if you click on it, then a little box comes up that says resistor, and you can change the value here. You can see it changes the stripes as well. So if I change my stripe here, if you watch carefully at the stripes, that middle one changed. That's like a code to tell you how strong the resistor is. I don't know the code. I always have to look it up. But lots of people do know the code if they do that, if they work with resistors a lot. Oh, sorry, I unclicked on it. There you go. All right, we just have one more component to finish our circuit. So we're really nearly there. I think this is the fastest we've ever gone through this bit, Dane. So people are clearly doing very brilliantly. You should all be very proud of yourselves. All right, so the final bit is to to finish our circuit off and to go from, we get our circuit's gone all the way along here, through the LED, through the breadboard, through the resistor, and now it's connected to these ones that are green highlighted on my screen. So all of the ones here along next to this blue line. So I'm going to take a wire and I'm going to take it back to the Arduino. So I'm going to click on one of these, and then I'm going to turn it to the little pin on the Arduino that says GND. Now that stands for ground. It's basically, this is the end of my circuit, everyone. And then it's connected. All right. Actually, you know what? I'm going to turn it over here. And then remember, I'm going to double click on my wire so that I can make it nice and neat. Like that. And Dane said earlier that I was going to use different colored wires to do things, and I'm going to do that now. So if you clicked on a wire, you can change the color up here at the top. So if you click on that, you can choose what other color you want it to do. So I'm going to turn this brown because it's going to the earth. And in all of my circuits, anything that goes to the ground or the earth, I'm going to always use a brown wire. And I'm going to use green wires to send instructions out to my circuit. So I've got a green wire that we're going to say LED turn on, and I've got a brown wire that's going to connect back to the ground. Like Dane said, you don't have to follow those rules, or you can make up your own. But I just find that it helps me to follow what's happening on my circuit and make sure that I know I've got a complete circuit. So give me a hands up if you have a complete circuit as well. Brilliant. Fantastic. I've got some thumbs up, some hands up. Oh, some smiling faces. Wonderful. Oh, and even some party celebrations as well. I love it. Great job, everybody.
Good.
All right. So this is a nice, simple circuit, which is good, and it's a great beginning step. But just to let you know how important this kind of thing is, we actually, in our lab, which uses some of the most advanced science in the whole world, we use circuits just like this to do all kinds of different things. We use Arduinos in our experiment. We code them as we're about to do, and we create the circuits just like you're doing. So all of this is really important to us and to science. So well done. I'm glad you're doing brilliantly. All right, so now we've got our circuit. You can trace it for a complete path, a complete circuit, all the way here, all the way here. Choom. You don't have to make the noises when you trace it, but I often find that I do. I don't mean to, but it happens. Right. Now we're going to do my favorite bit of it, which is the coding bit. This is the bit that I like the most. So you can see up here on the right-hand side, I'm actually just going to switch things around a bit so that I'm looking at you on a different page. You can see over here on the right-hand side. Oh, there. Can you still see it? That working? Right. On the right-hand side at the top, I've got this button that says code. Okay. So we're going to move this just to the side. If you want to move your circuit around, you can just click your mouse somewhere where there isn't a component and then drag your mouse around. Okay, so I'm just moving my circuit over here to the left a little bit so that I've got space, because when I click this code button, this code is going to come out from the right-hand side and we're going to be able to use this to send instructions out to our circuit. Okay, now those of you who have used Scratch will probably recognize this because it looks just like Scratch, which is really, really helpful. Just like Scratch, you've got different commands, different blocks that you can use. And Tinkercad, for some reason that I've never discovered, whenever you create a new piece of code, it says, it's like, oh, I'll be helpful. Would you like to do this? And that's not what we want to do. So the first thing we're going to learn about coding is how to delete things. So it actually works just like Scratch. So if you don't want a piece of code, if you put the wrong bit in, you just click on it, and then you can either pull it over here to the left and it disappears with a fun noise, or you can pull it down here to the bin and it disappears like that. Okay, so that's just like in Scratch as well. So the instruction that we want to do is we want to turn our LED on, and we want our LED always to be on. You may have used forever loops before in Scratch. So this is just an instruction to our Arduino that says, Arduino, I want you to do this thing forever and ever and ever and ever. And if you look here, you can see all of the different things, and that is in the orange one called control. So what we're going to do to start with is going to click on control, and then we're going to find the one that says forever, which is the second one down, and we're going to drag it over here to the right and make it our very first bit of code. Okay, so now I've got a bit of code. Whatever we're going to put inside this, the Arduino is going to do forever and ever and ever and ever, or at least until we turn its power off. Okay, so once you've got forever, what we want to do is we want to send an instruction out. And therefore, we need to look in the set of blocks called output, because we're sending an instruction out. So if you click on output, you can see all of the different things that you can do. All right, so we're just going to take one of these and tell the Arduino to do it forever. And the instruction that we want to send to start with is we want our light to turn on. Okay, now Sometimes computers use the phrase on, sometimes they say high, sometimes they say 1, but it all means the same thing. So you can see here, the second command down says set pin 0 to high. Now you'll remember that I called these little holes in my Arduino's pins. That's because in real life you put little pins in them. And you can see here that they are numbered. We've got different numbers next to them. And what we want to do is we want to send an instruction turn on or turn high to pin number 4, because that is the pin that my LED, my light, is connected to. So we're going to send this out and we're going to clip it in here. Makes a very satisfying little pop noise when you are, and I'm not sharing my sound, am I? Let's see if I can share sound. Oh, I'd have to close it. Just here we go. There you go. All right.
Sophie, I definitely heard a little pop noise.
I heard a pop too.
Marvelous. Well, I'm going to move it and then make the pop again.
Do it again. Do it again.
Move it around. Pop.
There we go.
It's such a great noise. That shows you that it's in the right place and it's connected. All right. So forever, this is going to say Arduino. Forever, I want you to set pin 0 to high. I want you to turn pin 0 on. But my LED is not connected to pin 0. So we have to do one more thing before we are ready to see if this works. And that is change this pin 0 to pin number 4. And now you see it says pin 4 to high. And that's the pin that my light is connected to. So raise your hands when you have got to this point. Brilliant. Or you can do a thumbs up, a reaction. Great job, everybody. Oh, fantastic. Oh, I can see a Statue of Liberty. That's a pretty cool reaction. I did not know that was one that we could do. I love it. Oh, excuse me, everyone. You're all doing really, really well. Don't worry though if this is the very first session. So this is just about us getting used to the coding, getting used to the environment where we do the coding. And so if you have missed anything, if you're like, oh, actually, I need to eat this biscuit, and you missed the step, that happens to Vicky and I quite a lot. We like our biscuits. Then that's okay. It's recorded. You can come and watch the recording later on. Okay, now, finally, before we complete our very first task, I'm very excited. I want to show you one of my favorite things about Tinkercad. Now, so at our lab, all of our scientists and engineers and technicians, they do really, really big experiments. But often the big experiments they're doing are really complicated and involve really expensive bits of kit. And we want to be fairly sure that nothing bad's going to happen, or that we can test it out first and stuff. So what we do is we model it, we simulate it. So we pretend that we're doing the experiment, we watch what happens. And then if it's like, oh yeah, okay, nothing blew up, that's great. We'll do that. Tinkercad can do the same thing. So it can say that even though I don't have a real Arduino, the computer will pretend that this is a real Arduino. This is the code that I've given it. And it will say, well, okay, if you gave that code to a real Arduino, this is what would happen. So if we press this button up here, this start simulation, it will run the code. That's what we say. It will do those instructions and see if it works, which is a great way of checking that your circuit is designed right and your code is written right. Okay, so if we've done this right, when I press start simulation, my light should turn on. So we count down, we can all do it together. So if I count down from 3 and then everyone press start simulation, then if it works, give me a big thumbs up. If it doesn't work, don't worry, we'll figure out what's wrong. Okay, so 3,
2,
2, 1,
1.
go. Yay!
Hey.
So did you see my little light here has now turned on? It's nice and bright. And I can see that some of you have got a light that's turned on as well. Fantastic. Great job, everyone. Don't worry if it's not working. If it isn't working, what would be really helpful is if you pop in the chat that says yours isn't working and give us the number of your Tinkercad login code. That means that Dana or I or Vicky can have a look at the code and we can give you a hint about what you think we think might be the problem, and then you can have a look, try and tweak it and change it, and then see how it works. Okay, so don't worry if it didn't work first time. I know this will shock everyone, this is not the first time I've made this circuit. I practiced. In fact, I practiced, even though I've done this lots before, I practiced about 15 minutes before we started this, just to be sure. I had it all in my head and all right. So it often doesn't work the first time. That's okay. One of the most important skills for a technician or an engineer or a scientist that we really value is perseverance. So often, most of the time, it doesn't work first time. We just try again, and then we try again, and we ask our friends and ask the teams that we work with about what they think the problem could be. Okay, so like I said, Dana's on it in the chat. You can have a look at your code and give you some suggestions. But while he's looking at specific codes, I will just let you know what the most common things that go wrong with this circuit are. The first most common thing is that actually your circuit isn't quite correct. It's not a complete circuit. So it's a good idea to trace your circuit all the way through. I'm just going to stop the simulation now so that we can highlight the components. So we started our Arduino, we go all the way through the wire, through our LED, through the breadboard. You can see I've got my green highlights. Yes, this leg is connected to this resistor. That goes through the resistor, then back to the breadboard. Oh, that's connected to all of these green things, which is connected to this wire, and it's connected all the way down here through the wire back to my Arduino. Okay, so check that and check that your brown wire, this wire here, goes to the pin that says GND, right? Ground, that's where it should go. So for instance, if I'd put my resistor just one step to the left over here, it wouldn't be connected because it's not, the green circles don't connect to the LED, okay? So that could be a problem. That's often the mistake that I make most often. The next most common mistake is, if you look at your code, is putting the wrong pin number in. So my light is connected to pin number 4. So I've got pin number 4 here. But if I had pin number 2 here, say, if I pressed start simulation, nothing would happen because I'd be saying, Arduino, turn pin 2 on, and the Arduino would say, okay, there's nothing connected to pin 2, but I'll turn it on anyway. My light is not connected, so it doesn't turn on. Okay. And then the final thing to check is this, my LED. Now, LEDs are a bit of a funny component, and that's because they only let electricity flow through them in one direction. Okay? It's the way they're set up, and that's actually really, really useful for us when we're building real circuits. But it means that they'll only flow through it in one direction. So if, for instance, instead of connecting my wire to this little leg that's at an angle, I had it connected around like this with my resistor on the other side, then it wouldn't work because the electricity doesn't like to flow through the light in that direction. Okay, so that's another mistake. That happens to me when I'm doing it in real life a lot. Okay, right. So I can see that Dane is doing a splendid job at heading out all of the at handling all of any questions, and I can see that all of you, lots of you, have done brilliantly and have already got it working, which is marvelous. You should be very proud of yourselves, everyone, for getting it work and for persevering when it's not working.
I actually think it's better sometimes when it doesn't work first time, because
I do.
you know, when you're kind of copying something, or maybe learning a foreign language or anything that's new, you sometimes are kind of just repeating back what someone else is telling you, and you're not always thinking about why is it doing it the way that it's doing it. So you're just copying, almost like copying someone drawing a star or something like that. And it's like, oh, this is what I'm going to do. My thing goes up and down and left and right, but I don't really know why it's this shape. Whereas if you're forced to kind of fix a problem, which is why we do the troubleshooting, which is going to start in a few minutes, which is why we do the troubleshooting, to help people kind of work through why it's not working. So sometimes the troubleshooting is the best part of the session. So
I think so.
Please stay behind if you can, and we'll fix it up.
Absolutely. And it's so satisfying when you get it to work. All right. So I think we've got just about enough time to do one final thing. So Vicky and I don't want just a normal star. We want a star that's twinkling, don't we, Vicky? Because even though Mars has, so did you all know that stars twinkle because of the air, because the light gets wobbled as it comes through the air? Mars doesn't have the same kind of air as the Earth, but it still does have air. We wouldn't like to breathe it. So our star is going to be twinkling. So I want my light to turn on and off. Don't I, Vicky? Yeah?
I think so, yeah.
Right. So what we're going to do is I'm going to set my light to turn on and then off. All right. So go back to the code. Remember, that's this block up here. This little switch up here. So I want my light to turn on, and then I want it to turn off, and then I want it to turn back on again, and then turn back off again. All right. And I want to do that forever. So I'm going to tell so at the moment it says turn on. Now I want it to wait for a little bit before it turn off. So in Control, I think just like in Scratch, there is a command that says wait. Might be pause in Scratch. I can't remember. If you can remember, let me know in the chat. But I'm going to take the wait command, which is the third one down in Control, and I'm going to pop it in my forever block. It makes that nice click, pop sound into there. So I'm going to turn it on, and then I'm going to wait for a second. What I'm going to do next is I'm going to get it to turn off. So it's just the same as this first command. So I'm going to look back at output, but instead of turning it high, I want it to be low because I want it to turn off. I want my light to turn on and then off, and then on and then off. Okay, but can you spot the mistake? The one thing that I need to finish doing? It's wait in Scratch. Thank you, everyone. All right, so remember, I need to make sure that I'm sending the instruction to the right pin. So here, I'm going to change this to pin 4 because that's what my light is connected to. Now, this looks like it will twinkle, and actually it will twinkle. It will turn on, it will be on for a second, and then it will turn off, and then it will turn on again. But I need to put one more command in, and that's because the Arduino, my little computer, is much quicker than my eyes. So it would turn off, but then it would turn on again so quickly that I wouldn't see it turn off. So I need to get it to wait again, so I can get it to flash. So I go back to Control, back to wait, and I pop that in there. So now it's going to turn on for a second, turn off for a second, and then it will go back to the start and turn on for a second and turn off for a second and back to the start. We hope. If you want, you can change how quickly it flashes. So I'm going to say, actually, I'm going to do it every half a second. So you can just put whatever number you want in there. All right. So in the last 2 minutes, we will see if we can do that simulation. All right. So you ready to simulate? Ready to make the twinkling star? Give me a thumbs up if you are.
Let's go.
Yeah, Dane's ready. Fantastic. Good job. All right. So remember, if we want to test out if our circuit and code is working, we press this Start Simulation button at the top. So I'm going to cross my fingers because it's always helpful, and then see if it works. All right, it's thinking about it. It's on and off and on and off. Yay, we have a twinkling star, Vicky. Have you all got, let me know if you've got a twinkling star too, by doing a hands up or a reaction. Fantastic. Well done, everybody. All right. Well, you should be incredibly proud of yourselves. You've done fantastically. I don't think I've ever seen so many thumbs up so quickly, so early in this course. So be very proud of yourselves. Remember, if it doesn't work the first time, that's not a problem. We can help. And in fact, as soon as we stop the recording, we'll go into our troubleshooting time when we can share our screens and look and see what is happening so we can figure it out together. All right, so thank you so much for your help, everybody. I will hand it back to Dane to finish up.
Thanks so much, Sophie, and really well done to everyone who's had a go today at making this circuit and the blinking light. If it's worked, brilliant. If it's not, don't worry about it. It's, as I was saying before, sometimes it's more interesting when it doesn't work first time. The thing that we need to make sure we do throughout the whole course is be kind to ourselves and not get too frustrated when things don't work as we like. So I think everyone's done really well. There's been a few glitches along the way, which we're going to iron out in the next part. But you can always have a go again. Sometimes when you're new to something, it's best to kind of start from scratch. And if you want to do that by looking at the recording when we send that round, or there's the worksheet that's already on the Glow Your Own Session 1 webpage on if-oxford.com, you can just look at that again. And now you've seen the whole process go through once, the worksheet might make a little bit more sense, or certainly more sense than it might have done before we had this session today. So there's plenty of time to learn how to do this. It's not easy. You've learned how to use Tinkercad, you've learned how to use circuits, you've learned how to do all sorts of things that are new. So be pleased with what you've done today. And next week, we'll take it one step further. And that's what we're doing. We're going to be just building on this step by step. So we'll take things forward. My doorbell is going. So I'm going to stop the recording and we will see you all next week for more coding. But for those of you who are able to, stay behind and we'll do the troubleshooting and we'll solve some of your problems. But thanks so much for coming and well done. See you next week. Bye.
Bye.
Bye, everyone.
Thank you.